Today we're going over homework 28, problems 7.3, 3, and 13. An element in plane stress is subjected to the following stresses. Determine the principal stresses and show them on a sketch of a properly oriented element. The only thing different between this and our previous homework assignment is now we need to use the equation that gives us our principal angle. The angle that finds the stresses for our minimum and our maximum possible stress state. So, plugging all of our information, we'll get 90 degrees, and recalling that our two stresses are perpendicular, therefore their angles are perpendicular, we can have our other angle of 99 degrees. If we plug in our two angles into our really long stress equation, and all of the other information, we're going to get our two stresses. Now in principal stresses, when you're specifically looking for your sigma 1 and sigma 2, your tau will always, in every case, it will always be 0. And the only reason it wouldn't be is if you are, instead of finding your principal normal stresses, if you're finding your principal shear stress. If you're finding principal stresses, you will have 0 shear unless it is your shear that you're looking for. And in the case that you are looking for your principal shear, that does not guarantee that your normal will be 0. It's just in one of the cases. So, it also asks us to sketch it. If we have our small angle of 9 degrees, our sigma 1 is the one that was associated with that angle, which is why we put our 5.9 KSI at that one, and then our 1 KSI at the other side, and then of course there is no shear. A shear wall in a reinforced concrete building is subjected to a vertical uniform load, a horizontal force, and as consequence it has the following stress state at this orientation at that location. Determine the principal stresses and show them on a sketch of a properly oriented element. So we're going to do the same deal. We're going to want to find our theta. This time I'm not dividing by 2 because then I can just plug in our thetas directly into my equation. And I get that for my negative 20 degree angle, because again this is half of my 2p that I solved for in the first step. I have my negative 41 and half of that, which is my principal angle, is negative 20. For that one, when I put in everything, I got a sigma of 180 psi and negative 1300 psi for my other angle. Then I can check with my equation and see, yes, they are in fact the sum of my initial stress states and the sum of my new stress states are in fact equal to each other. And this, you can either use this method to check your work, or you can use it if you don't want to plug in all of your information to find sigma sub 2. You can just say, okay, I'm going to subtract sigma sub x1 from my original stress states. Either way, now that we have this information, we can sketch it. And this is what my sketch looks like. Because my angle for my x1 is negative, we have a downward shift. And then, of course, my other one is perpendicular and has a negative magnitude. So if I were to draw my arrow there, I could have it going upwards with the negative number there, or I could have it downwards with a positive value there, and they're exactly the same. Now it says, determine the maximum shear stresses and associated normal stresses and show those on a sketch of a properly oriented element. So my equation for maximum shear is the following, and this equation here we can use our principal stresses or we can use our initial stresses. It doesn't matter. Both of them work perfectly fine. So if I plug that in, I'm going to get a plus and negative value since we have a square root, and that is normal, and also makes sense due to the fact that our shear is you're going to have arrows in both directions. So, if you did want to use the principal angles, since our principal stress state does not have a shear, you would have just subtracted the 2 and divided by 2, and since you square it in square root, we're going to get 730, and this will make it less ambiguous of which direction you want to be drawing your towel. So this is my preferred method, but you can use the other one, and if you can conceptually figure out whether it needs to be positive or negative, go for that, assuming you haven't solved for your principal, because that will be faster. But if you are solving for your principal, I'm just going to do this because that is a lot easier for me. Now that we have the magnitude of our maximum shear, we still need to find the angle and the magnitudes of our normal stresses that will be acting on that plane. So for both of those, there's some things that you need to know about how max shear planes work. So our maximum shear will be located at an angle 45 degrees offset from our maximum normal. And this is really cool because all you have to do is, if you've already found theta for your principal axis, then you just subtract 45 degrees and bam, there's our angle for a max shear. And this is equivalent to if you had added 45 degrees, because you would have, if say, for example, if we have our square and we rotate it negative 65, and now if we add 90 degrees to that, due to the fact that it's a square shape, it's going to be the exact same shape. The only difference here is that our towel would be pointing in a different direction. But even our X and Y stresses will be unaffected, because another cool rule about max shear states is our X and our Y are the same magnitude. So because of that, it makes it easy to solve for the magnitude of our max shear in the our max stress in our max shear state. And the reason for that is because if we recall our summation rule, where the sum of two of our stresses in one state is going to be the same as the sum of our stresses in another state. Right here on the right side of my equation, I have my initial state, which is sigma x plus sigma y, so 1100, rather negative 1100. That's going to equal the summation of my stresses in my shear state. However, since I know that they have to be the same, it's just going to be 2 multiplied by some sigma that they both share. So I can say both of my x and my y normal stresses have to be negative 550 psi for this state. So when I draw it, I have my shear going in my positive 700 direction, and my y and x, again, because it's negative, you could have drawn a down arrow with a positive 550 or an up arrow with a negative 550, and they're exactly equivalent. And it has this angle of rotation for our element. I'm going to purposely not go into concepts behind these equations, and the reason for that is because in our next lecture we're going to go into that in detail, where you'll learn the other method that you can use to solve for principal stress elements and angles and so forth. So basically, just know these two equations. That's like 90% of what we just did, except for the shear, and there wasn't too much new about that. But we will go into the concepts and equations after we learn the other method, because if I go into it now before we learn the other method, then it kind of spoils some stuff, and I don't want to do that. But anyways, I hope this was helpful, and good luck in homework.